Okay, rolling on here with the second half of the Honors Algebra 2 Semester 1 Multiple Choice Final Review. We are going to identify where the function that we were just working on here a moment ago above is increasing. So, let's get this back up. Fortunately, I somehow have cleared it out. Brilliant move on my behalf. Alright. So let's get that back up. And we want to know where the value is increasing. Well, I notice here from the start of my graph up until my max here that it's increasing. So, it's increasing from negative infinity. I'm going to leave a blank here for right now. To that max x value. Then it starts to go downward until it gets to the minimum. Now the minimum, I do know the x value is at 3.23. So, from 3.23 down here to infinity, I know that it's increasing. So my question now is, where is it stopping this first time? What's the x value at this point? So if I do second trace, I can find my maximum. Actually, I look like I'm pretty close there already. So 1, 2, 3, just like when I'm finding a 0 or anything else, enter. 2, 3, 2, 3, 6. Trap that guy in. And my x value at this point is 0.10. So from negative infinity up till 0.10, I'm increasing. And from 3.23, again, my x value up to infinity, I am also increasing. Just looking at those values. And you know what? On a multiple choice, they're probably going to be close enough. You could kind of just wing it, to be perfectly honest. Right. 27. Which of the following is a graph of? Now, let me give a couple of hints to make life go pretty quickly for you on this. Because again, when we're doing a multiple choice test, one of our biggest issues is basically going to be dealing with, how can I do this quickly? So what do I notice? Well, my vertex looks to be up here in quadrant 1. That one's in quadrant 2. That one's in quadrant 2. And they're both, that one's even opening the wrong way. And then this one is opening in quadrant 4. Wasn't that fun? Okay? Keep it simple. Don't overthink. Solve the inequality. Write your answer in interval notation. Okay? So we're going to factor it. At this point, again, on a diamond, we got to be able to do that quickly. Now, here's a couple things I know. And we'll chat about what I could have done with these here momentarily. So again, we've talked before about when I answer these, either my answer is going to be in section B or it's going to be in A and C. How do I know? I use a test point. So if I plug in 0 to my original problem, I get 0 minus 0 minus 21 is less than 0. So is negative 21 less than 0? It certainly is. Which tells me that's where my shading is. And that my interval notation goes from left to right. Now again, could I have looked at this and seen it was an and statement and kind of known the same thing? Sure. But again, there's different ways to be able to get there. Okay, 29 was actually an issue we had, I remember, at least on one quiz, if not two. Our problem here isn't knowing to square both sides. That's not the issue whatsoever. My issue is right here. This has to be boxed or foiled. You can't just say x squared plus 4. It'll be wrong. If you need to, write it out so you can physically look and go x squared minus 2x minus 2x minus 4x plus 4. Okay? Otherwise, it's kind of tricky. Everything to the x squared side. So I'm going to minus my x over. I'm going to add my 6. And then at this point, I'm going to try a couple of things. First, I'm going to try to factor it. But if it doesn't work, yes, I'm going to have to go to the quadratic formula. So the opposite of b, plus or minus the square root of b squared minus 4ac over 2a. And again, since we're looking for exact values, if you're going to put this part into the calculator, I would do it without the radical, negative 15. So, a couple things to notice here. One, I need to take an I out. Secondly, I can't break down the 15. So in this case, that's as far as I can go. So don't overthink. And again, once you start having choices, you could even plug the choices in, let's be honest, if you wanted to on that. Okay, here, not multiplying, just distributing the negative. Don't touch what's in the first part, but I change signs on everything that's in the second. And then I combine like terms going from the greatest degree down to the least, because we want to be in standard form. So we got 6x to the 5th. We have one term to the 4th. We have one term to the 3rd. Couple of terms squared. We're set with that. But no multiplying. My goodness, don't try to box that. That'd be ridiculous. All right, bakery sells cupcakes. Oh, it's your lunch. I'm getting hungry. So the revenue of the sale of cupcakes is given by 1.50x. In other words, you're selling the cupcakes for $1.50. Suppose the function for the cost of baking is this, right? The profit function. Revenue minus cost. And here's where people get in trouble on this. They do this. And the problem is you're subtracting that whole quantity. That minus is going to distribute through, as I lost my x. See, those are the things. I'm telling you, it's good to see me doing it on this, because it's like, dang, if he does it, I really do got to watch it. And then go ahead and combine my like terms to get that situated. And we're set there. Which is the correct equation for the graph shown. Now again, you'll have choices, but for now we got to remember, oh yeah, I need my center and my radius. So let's see here. My center's at negative 2, 1, 2. My radius looks like it's 2. So when I'm looking at the options, I have to remind myself, when I'm looking for these, it's opposites on both. So plus 2, minus 1, and my radius squared. So x opposite of h, y opposite of k, and my r squared. But again, you'll have choices. That's the big thing to remember here. Let f of x and g of x. Find f times g of x. Whether you FOIL or whether you box, we're just multiplying. It's not a composition. So 3x squared plus 21x minus 2x minus 14. Combine my like terms in the middle, but again, with choices, you're going to know this. Good. And then my last function down here at the bottom, find p plus q of negative 9. In other words, plug in negative 9 to p, get an answer. Plug in negative 9 to q, get an answer, and then add them together. 2 times negative 9 is negative 18, but it's absolute value. So that'd be 18. Negative 5 times negative 9 is 45. 6 plus 45 is 51. Add those guys up. Okay, so this stuff really isn't bad. Again, it's detail and take your time, which is nice that we're only doing the multiple choice part as we get forward here. Okay, what's the inverse of f of x? Remember, f of x, fancy way of saying y. To find the inverse, we switch the x and y, and we solve for y. So I minus the 8 over. And then when I go through and divide by 2, the answer could be written one of a couple ways. If we went through and divided everything by 2, 8 divided by, could be written this way, more of a slope-intercept form, or it could be written fractionally. Okay, you got to be prepared for either one. But as long as you remember switch x and y and work that through, you should be fine. Polynomial is an expanded form of which of the following? So again, it just means basically there's going to be all these factored forms down below. And so you'll look and you'll say, well, what do I square to get 3? I mean, what do I square to get 3? What do I square to get 9? Wow. What do I square to get x squared? What do I square to get 49? What do I square to get y squared? And to get a negative product. That'll be one of your choices, and it basically is if you box this out, which one of the boxes is going to get you back to this answer? And you're set. So as we keep rolling along here, factor completely. We're going to pair these guys off. What do they have in common? Pull it out. Leftovers stay inside. What do they have in common? Pull it out. And the leftovers, again, have to match. Otherwise, this is no Gouda. So then your answer is just the pair they have in common. And then the greatest common factor that's left over. And we're set. 38. Gotta recognize these are cubes. If you don't, this could be problematic. So we talked about that on the Grace quiz, and we got it again here. So when I'm doing my form, write my values, take the sign in the middle, and then it becomes square my first term, the whole term, the number, and the variable. Switch signs, multiply them together, and square my last term. So once again, square the first, times them together, square the last. And then 39, we'll keep 37 in view here, is going to be very similar. Take out what they have in common. Whatever's left over, again, you add exponents, you multiply coefficients. Now then you get to this last part, and you're like, because here you're like, well, they each have 2, and this might be the first one of these that Harty pulled a bonehead on. And I did. I did. In trying to change the problems to make this work, I messed this up. Oh, the pain of it all. You're like, well, how do you know you messed it up? Well, I can tell you at first here how I know for sure I messed this up. Because when I look at this, those two guys aren't even close to being the same. I must have started changing the first half and I didn't change the last half. So, yeah, Harty. All right, 40. Let's get back on track here. Given f of x has 1 0 at 6 plus I, find another 0. This is how straightforward this one is, and we didn't talk about it much. If you have one at 6 plus I, 6 minus I has to be another one of your solutions. Whenever there's an I involved, you have to have the positive and negative as one of your values. I know it's not talked about, but it's kind of easy. So keep that one there. All right, we're down the home stretch. What's the remainder when f of x is divided by x minus 2? Remember, switch your sign. Make sure there's no gaps. 3, 2, 1, 0, and there's not. Drop that first term down. Multiply. And add down. Multiply. And add down. Multiply. And add down. And since I'm just being asked for the remainder, that's all I need. And I'm ready to go. And last one on this page, synthetic division. Same idea. Switch your sign. But be careful. 3, 2, oh, missing a term. Make sure that term gets situated. 1, 0, negative 14, 8. Otherwise, everything's the same. I just had to make sure in that one spot I made sure I was good. So again, multiply and add. And here, since we're finding the quotient, I actually have to put the variable terms back in. So when I do that, start one lower than the degree I started with. So squared, x, constant, and I don't have a remainder this time. That gets us rolling to the back page here.